Hi, everyone. Okay, we are on surface area and volume of spheres. So here are a bunch of different examples of spheres in the real world. I think my favorite is the bubble boy. Those things look fun, yet I think I'm slightly claustrophobic, so I'd be afraid. I don't know. Can't decide. Looks like a good time though. But we're going to watch a little clip here to help us figure out the formula for surface area of a sphere. Okay, so normally we would do this in class and I'd bring in QDs for everybody, but again, COVID is ruining everything. So we have to pivot a bit and we're going to watch it. But what's happening here is this person is tracing out the orange, okay? And they're going to do it 4 times. So there's one, and you ideally would make them congruent circles since it should all be the same, since it's the distance around that specific orange. Then we're gonna kind of fast forward. Yep, we're still just, making the circles. We have 2, 3, 4. Okay, and now we're gonna take the peel of our sphere and fill up as many of these circles as we can. We'll see how many we fill up with that peel. So again, we're going to fast forward a bit here because we have the luxury to do so. And we see that we completed that one, so we're going to move on to the next circle. And again, we're going to rip it up into pieces to cover up that full circle. And we're going to keep going. And I hope you're thinking, why am I doing this? Well, what does the peel represent? And it represents the surface area of that orange or our sphere, right? So we are trying to figure out what the formula is. How many of these circles are we going to fill up? Right now we have 3.5. Are we going to get 4? Are we going to get 5 filled up? And keep going. And we want it to be completely filled in these circles. And looks like we fill up about 4 of the circles with our peel. So what is the surface area formula? Oh, well, spoiler, it doesn't even tell you. I'll tell you. Oh, geez, we gotta stop this. Okay. This seems kind of a train wreck, you guys. It's more fun when we do it in person together, but try it at home if you want. But anyways, the surface area formula is 4 pi r squared. And just a way to help you remember it is if you were to do that, the peel of your orange would fill 4 circles. Because we know pi r squared is the formula, or is the area formula for 1 circle, and we're going to take it times 4 because our peel filled 4 of those circles. Volume I don't have a fun video for volume. It's 4/3 pi r cubed. Take volume, our units are cubed, so we're going to take our radius to the 3rd power and then 4/3 in front. But make sure you have those written down correctly, please. We also have one new vocab term, and it's a great circle. And the great circle is the intersection of a plane and a sphere, but it has to pass through the center of the circle. So basically, if you were to cut a sphere in half, as long as you pass through that center, the circle created by that cross section would be considered a great circle. So as long as it goes through the center, it's a great circle. Whereas you guys see these ones, like this little circle here, if I were to slice that little chunk off that sphere, this circle created would not be a great circle since it's not going through my center right there. Okay, so just know that a great circle has to go through the center of your sphere. Right, we're just going to try some very straightforward examples to start with. It says find the surface area. So that is our 4 pi r squared formula. Our radius would be half of 22, so 11. So 4 pi 11 squared. Again, this is calculator work. You simplify as much as you need to. I'll do it in a couple steps here. 11 squared is 121. 4 times 121 is 484. take that times pi, you should get approximately 1,520.5 feet squared. That's it. That was just a nice calculator work problem. Now we're finding the surface area of this dome or this half or hemisphere, right? You could say. So I'm going to start off with the same formula, 4 pi r squared. Plug in our radius, 2.8 squared. Again, I'm going to simplify. If you want to plug that into your calculator, go right ahead. 2.8 squared is 7.84. Multiply that by 4 and get 31.36 pi. Multiply that up by pi, and we should get 98.52. Okay, now that would be if I had a whole sphere, right? But I only have half of it. So we have to divide this guy by 2. So 49.26. Okay, now folks, however, we just got like the dome, right? We got like the bubble, but we haven't accounted for this great circle or that space, that bottom, right? That's still part of my surface area. So we have to find that using pi r squared. So pi 2.8 squared. We already said that 2.8 squared is 7.84. Multiply that by pi, we should get 24.6-ish. So now our total, 24.6 plus 49.26 should give us a happy number of 73.89 centimeters squared. Perfect. Okay, now we're going to work backwards. This time it says find the surface area of a hemisphere, so half a sphere, if the circumference of the great circle is 36 pi. So basically, this problem's not hard once you figure out our radius, but we don't know what our radius is. But we do know our circumference, and we know circumference equals 2 pi r. And we know in this circle, our circumference equals 36 pi, so I'm going to plug that in for C. So 36 pi equals 2 pi r. And now we just have to get r alone. What's nice, folks, is look, our pi's go away. Now we can divide by 2. So 18 equals r. And now it's a pretty easy problem because we just plug into our surface area for a sphere. So 4 pi r squared is our formula. And now we plug her in here, 4 pi 18 squared. Again, calculator work, you simplify as much as you need to. 18 squared is 324. Multiply by 4, you get 1,296 pi. Now I'm wondering if my P, you guys, is wrong, so give me a second here. I just want to make sure I did something right. So 1296 times pi. Yep, because I didn't do it right in my notes. That's okay. So multiply by pi, folks. You get 4,71.5. Okay, that's for a whole sphere, but we want a hemisphere, so divide that guy by 2. And we should get 2,035.75. Okay, so that is for the dome, right? But then we just, in the last problem, we still have that bottom circle, that base of our hemisphere. So now I'll just put base, pi r squared, pi 18 squared, pi times 324 324 times pi is approximately 1,017.88. Okay, folks, add them together for our totals. Oh no. Why? For our total surface area. There we go. Together for our total should be plus 2035.75. 3,035.63. I don't even know what our units are. We have units. Centimeters. Woohoo! Squared. Good job, team. Okay, one left. We'll try a volume problem. Find the volume of a sphere if the area of the great circle is approximately 249 square millimeters. So again, they're making us work a little bit. We have to find our radius first before we can plug into our volume formula. So a great circle is just a circle, right? Area equals pi r squared. And we know that area is approximately 249, so we'll plug that in. We want to get r alone, so let's first divide by pi. And we'll get 79.25 equals r squared. How do you undo something squared? Well, you take the square root. So we find that our radius is about 8.9-ish. And now from here, we simply plug into our formula. So 4/3 pi 8.9 cubed. Again, you do as much as you're comfortable with typing in your calculator or phone. I'll break it down how I would do it. I'm going to take 8.9 cubed, which is approximately 705.6. And now I'm going to take 4 times that 705.6 and get 2,822.5 pi all over 3. Running out of space per usual. Now I'm going to take that 2,822.5 and multiply it by pi. So 8,867.15, then divided by 3 for an approximation of 2,955.71 millimeters, and that's volume, folks, cubed. Thank you for watching this great lesson on spheres. Until next time, hit the subscribe button. Goodbye.